All right, and welcome back. So today we are going to be talking about simple interest and compound interest. We're mainly going to be focusing on compound interest, but it is good to compare simple interest to compound interest. So let's talk money. Real quick, just want to show you the equation that we have for simple interest. I is equal to P times R times T, where I is the interest that you are earning on your money. The P is your principal or your starting amount. R is going to be the interest rate earned, which we're going to be writing as a decimal. And T is going to be the time in years. And if we want to find the total amount that we're going to have after we occur this simple interest, we're going to add the interest earned and the principal amount together. So without further ado, let's go through two quick examples. So it says use a simple interest formula. I is equal to PRT, where I is interest, P is your principal amount, R is your interest rate, and T is the time in years to find the interest that is earned. So let's say you have $3,500 and you put it into a bank account, okay? And that account gets you 5% earned in 3 years. So to find the simple interest, we're going to start out with our equation. I is equal to PRT. We're trying to find our interest. Our principal amount is going to be right there, 3,500. We're going to multiply that by our interest rate, which is 5%. But we write that as a decimal, so that's 0.05. We're going to multiply that by the time that is occurring within this interest, which is 3 years. And with simple interest, it's always, or not always, it's mainly within years. So you take out your handy-dandy calculator and you type it on, 3,500 times 0.05 times 3, and you are going to be earning $525. So within 3 years, at 5% with simple interest, you earned $525 by pretty much doing nothing, just letting that money build its own, well, money. So now if we want to find the total amount, our total is going to be equal to the principal amount plus the interest earned, okay? So our principal amount, again, was 3,500. The interest that we earned was 525. Oh no, I'm running out of room here. So now we do 3,500 plus 525. And we get $4,025. So in 3 years, that account would have $4,025. It's a pretty good setup, right? What if we had a larger amount though? We have $250,000. Our rate's higher at 7%, and the time that's going to be occurring is going to be over 8 years. So again, we start out with our formula, and let's fill in the information that we know. We know the principal amount is $250,000. We're going to multiply that with our rate as a decimal. It's 7%. We write it as 0.07. Now we're going to multiply that by the amount of years, which is 8. Take out your calculator and multiply it all together. 250,000 times 0.07 times 8. Double check before you hit enter, and you get a whopping total of 140,000. So that means in 8 years, without doing anything to your money, guess what? You earned $140,000. So if you want to find the total amount, again, it's going to be the principal plus your interest. So their starting amount was $250,000. We're going to add that with our with our interest of $140,000, and we get a grand total of $390,000, which is incredible for putting your money into this bank where it's going to be gaining interest. They earned $140,000 by doing nothing, by just putting it off to the side and saying, hey, just let it build, right? Which is great. That's simple interest. And we're going to be talking about the beautiful thing with money. And as Benjamin Franklin puts it in a great quote, we're going to be talking about compound interest, because you can make more money with compound interest than it is simple interest. So here are the notes and our setup for compound interest. Compound interest is the interest earned on the principal and on previously earned interest. The balance y of an account earning compound interest is given as follows. Y is equal to your principal amount times 1 plus r over n, where r is the annual interest rate in decimal form, divided by the number of times the interest is compounded per year. Then all that is raised to the power of n times t, which is going to be the number of times the interest is compounded times the time in years. Okay? So, without further ado, let's talk about this great quote. Benjamin Franklin and compound interest. There's this great story about how he set aside $5,000 before he died for 2 cities and said, you can't touch this until 200 years pass, and the money is gonna grow compoundly. Well, guess what? That money in 200 years grew to about, I think, like $20 million. So $5,000 turned into $20 million. Thank you, BF. It says money makes money, and the money that money makes money. So that's all about compound interest. You're going to be making money and you put it away. And the money that's in there is going to be generating money. And the money that's getting generated is going to be generating money. So essentially what's going to happen here is, let's say we have $100, right? And we get, 10%, right? Per year. Well, now guess what? That's $110. Now I'm going to multiply that again by 10%. That's now $121. So you notice we don't really have a distinct pattern here, because we earned $10. And now we earned $11. Well, guess what? What's 10% of 10? $1. So the money that you have is generating more money, and your total keeps getting bigger and bigger and bigger exponentially. So without further ado, let's put it into a concrete example. That way, maybe this illustration in the bottom didn't really help you out, but let's talk about this right here. It says you deposit $1,000 into a savings account that earns 6% annual interest compounded monthly. Write a function that represents the balance after T years. Then, how much money will you have in 10 years? So, let's start out with our formula. So the amount y is equal to your principal times 1 plus r over n to the nt. Okay, let's fill in what we know. So when it says monthly, compounded monthly, that means there's going to be 12 times that compound interest occurs. So your n is going to be 12. So since our n is going to be 12, let's start to fill in what we know. Our principal amount is $1,000. Multiply by 1 plus our rate is 6% annual interest, so it's 0.06, so we write it as a decimal, over the number of times this is going to happen per year. And since it says it is compounded monthly, our n is going to be 12 because it's going to happen 12 times. Then it says we raise it to the n, which is 12 times t, and t is going to be the time occurring, 10 years. So now we plug it into our calculator and let's see what we get. 1,001 plus 0.06 divided by 12 we get 1.005 raised to the 12 times 10 is 120, and we're going to plug that in to our calculator. So remember how we plug it in: 1,000 parenthesis 1.005 close parenthesis caret 120, and we get a whopping total of $1,819.40. So that's how much money we will now have. We earned $819.40 here. That's the beauty of compound interest, because what is happening is it's using the interest rate and the number of times it's going to occur within the year, and it's doing it over and over and over and over and over and over. It has repeated multiplication, where simple interest is just one straight formula. It's the amount times our rate times the number of years. For compound interest, it's saying, okay, take this 6%, apply it, boom, apply it again, apply it again, apply it again, apply it again. And however many times we want to apply it, or is going to be compounded. That's the beauty of compound interest. Let's do one more example, and then I have something for you. So you deposit $500 into a savings account that earns 9% annual interest compounded semi-annually. Write a function that represents the balance y in dollars after t amount of years. How much money do you have after 12 years? Well, we start out with our formula. Y is equal to P times 1 plus R over N to the NT power. Our principal amount is going to be $500. Our rate of annual interest is 9, so 0.09. Over the number of times it occurs. Semi-annually means 2, by the way. To the n times t power. It's happening in 12 years. Let's simplify down. Y is equal to 500 times 0.09 divided by 2 plus 1. So 1.00, I'm sorry. 1.045 raised to the 24. Now plug it into a calculator, and we have 500 parenthesis 1.045 close parenthesis caret 24, and we get $1,438.01. Beautiful, beautiful. All right. Great job so far, folks. Great job so far. So we do not have time for the experiment, but I'll post a second video for that. But I have one more question for you. Please attempt to have completed this problem and then resume when you are ready to see the answers, as they are on another slide. For part B, it says how much money did you earn on compound interest over those 20 years? So what you want to do is you want to take the total money in your bank account and then subtract what you started with, and that will tell you how much you earned. All right, folks, here are the answers. Great job. If you have any questions, please feel free to reach out. This is a beautiful topic, so if you want to start looking into it while you're young, that would be great, or now, that's great too. Have a great day, folks. Sorry, I don't know how to end this one.